January 17, 1991. Western Iraq. Midnight burns without light. Captain Michael Harrigan of the United States Air Force sat inside the dim glow of his cockpit. The hum of electronics surrounding him like a second heartbeat. Outside, there was nothing.
No Geraisen.
No stars. Just a black sky stretched over a silent desert. But this was not the kind of darkness men feared anymore. Below him, targets waited, command bunkers, radar installations, hardened shelters buried beneath layers of concrete and belief. For decades, those structures had been safe in one simple assumption: if you couldn't see them, you couldn't hit them. That assumption was about to die. Harrigan's gloved fingers moved across his controls, steady, deliberate. On his display, a set of coordinates pulsed with quiet certainty.
No flares.
No visual confirmation. No desperate dive toward a target through anti-aircraft fire. Just data. Just precision. Just faith in something no generation before him had ever truly possessed. They used to call war a matter of sight. Of pilots squinting through glass. Of bombardiers calculating wind drift and altitude. Of men guessing, sometimes correctly, often not. But tonight, there would be no guessing. Because somewhere, far beyond the horizon, a missile had already been launched. It wasn't fast in the way fighter jets were fast. It didn't roar across the sky with bravado or challenge. It flew low. Invisible. Unseen. A mechanical ghost hugging the contours of the Earth itself. They called it the Tomahawk. And when it struck, it didn't just destroy a target. It ended an era. You see, for most of human history, war was limited by what the human eye could perceive. Cannons fired in arcs you could trace. Bombers dropped payloads you could watch fall. Even the most advanced weapons of World War II relied on visibility, on line of sight, on weather, on human judgment under pressure. Blind warfare wasn't just a limitation. It was the rule. And nations built entire doctrines around that blindness. Camouflage. Concealment. Hardened bunkers. Night operations. Smokescreens. Deception. If you could hide well enough, you could survive. That belief shaped strategies from Berlin to Tokyo, from Korea to Vietnam. Entire armies moved under the assumption that invisibility was protection. But what they didn't know, what they couldn't yet imagine, was that America had been quietly rewriting the rules. It started not with a weapon, but with a question. What if you didn't need to see your target at all? Back in the late Cold War years, engineers and strategists faced a problem that no amount of courage could solve. Soviet defenses were layered, dense, and deadly. Radar systems scanned the skies. Surface-to-air missiles waited with cold precision. Any traditional bomber force would be detected, engaged, and destroyed long before reaching critical targets. Bravery alone wasn't enough. They needed something else. They needed a way to strike, without being seen. At first, the idea sounded almost absurd. A missile that could travel hundreds of miles, navigate terrain on its own, and hit a precise location without direct human control? It wasn't just ambitious. It bordered on impossible. They laughed at the concept. They called it over-engineered. Too complex. Too dependent on fragile electronics. Too slow to survive modern defenses. But America had a habit of building the things others dismissed. Because this wasn't just about creating a new missile. It was about creating a new kind of warfare. One where distance no longer meant safety. One where darkness no longer meant invisibility. One where precision replaced probability. The Tomahawk cruise missile was not designed to win duels. It was designed to erase the need for them entirely. Inside its compact frame was something revolutionary, a guidance system that didn't rely on eyesight, but on memory.
Terrain contour matching.
Digital scene mapping. Systems that allowed the missile to recognize the RD beneath it, to compare what it saw with what it had been programmed to expect. It didn't need a pilot. It didn't need a spotter. It didn't even need light. It knew where it was, because America had taught it how to think in geography. And that changed everything. Because suddenly, the battlefield was no longer defined by what could be seen. It was defined by what could be calculated. Back in that cockpit over Iraq, Harrigan didn't watch the strike happen. He couldn't. There was nothing to see. No flash on the horizon. No rising plume of smoke visible from miles away. Just silence. And then, seconds later, a voice over the radio, calm, almost detached. Target confirmed. Direct hit. Somewhere below, reinforced concrete had failed. Steel hot bent. Command structures that once felt untouchable were now reduced to fragments. Not by chance. Not by saturation bombing, but by a single, precise, calculated impact. And that's when the world began to understand. War was no longer about who could see first. It was about who could think further.
They brought camouflage.
America brought computation. They trusted darkness. America turned darkness into a roadmap. It wasn't just a missile. It was the end of blind warfare. And the beginning of something far more exact. Long before that silent impact in the Iraqi desert, there was a quiet confidence shared by generals across the world, a belief so deeply rooted it rarely needed to be spoken aloud. If you could hide it, you could protect it. From the forests of Eastern Europe to the mountains of Central Asia, entire military doctrines were built around that single idea. Bunkers were buried beneath layers of earth. Command centers were carved into rock. Radar installations were masked, relocated, disguised.
And above all, they trusted the night.
Darkness wasn't just cover, it was strategy. You see, traditional warfare had always been bound by human limitation. Pilots needed visibility. Bombardiers needed reference points. Even the most advanced targeting systems of the mid-20th century still depended on line of sight, weather conditions, and human interpretation. Clouds could save a city. Smoke could hide an army. Night could delay an attack. That was the illusion. And like all illusions it held, right up until the moment it didn't. In the years after World War II, as the Cold War tightened its grip, the United States found itself facing an uncomfortable truth. The next war, if it came, would not be fought in open fields or clear skies. It would be fought against an enemy that had learned to hide, to disperse, to survive first contact. The Soviet Union didn't just build weapons. It built layers. Layered air defenses. Layered redundancies. Layered deception. Radar systems stretched across borders like invisible fences. Surface-to-air missiles stood ready, guided by cold mathematics and faster reaction times than any human pilot could match. Command centers weren't exposed, they were buried, shielded, protected by both steel and geography. To attack such a system with traditional means was to accept heavy losses. And America had seen enough of that. They had seen bombers lost over Europe. They had seen pilots shot down over Korea. They had seen, in Vietnam, how even overwhelming firepower could be blunted by terrain, concealment, and unpredictability. Courage was never the problem. But courage alone couldn't defeat a system designed to neutralize it. So the question changed. It was no longer, how do we strike harder? It became, how do we strike smarter? At first, the answers came in fragments. Precision-guided munitions began to emerge. Bombs that could adjust their path, guided by lasers or early electronic signals. They were revolutionary for their time, capable of hitting targets with far greater accuracy than traditional unguided bombs. But they still had one fatal weakness. They needed visibility. A laser designator required a clear line of sight. A pilot still had to approach the target zone. Weather could interfere. Smoke could obscure. Defenses could engage. The battlefield was still, in many ways, blind. What America needed wasn't just better weapons. It needed independence from sight itself. And that's where the real shift began. Deep within research labs and defense contractors, engineers started working on something different. Not a bomb. Not a rocket in the traditional sense, but a system. A machine that could navigate the world not by seeing it as humans do, but by understanding it in an entirely different language.
Terrain. Contours. Elevation. Patterns.
They asked a radical question. What if a weapon could read the LRD the way a pilot reads a map? What if it could fly low, so low that radar systems would struggle to detect it, and adjust its path based on the shape of the land beneath it? This wasn't about speed. It was about intelligence. They called the system TERCM, terrain contour matching. And at first glance, it seemed almost too complex to work. The idea was simple in concept but staggering in execution. The missile would carry a digital map of the terrain it was expected to fly over. As it traveled, onboard radar would scan the LRD below, comparing real-time data with its stored map. If the shapes matched, it stayed on course. If they didn't, it corrected itself.
No pilot. No external guidance.
No need to see in the traditional sense. It didn't rely on vision. It relied on recognition.
They mocked it.
Critics called it fragile, too dependent on data, too vulnerable to errors, too slow to be practical in a fast-moving battlefield. Some argued that electronic systems could fail, that maps could be outdated, that the complexity would outweigh the benefits. But what they didn't understand was this. America wasn't trying to build a faster weapon. It was building a smarter one. Because once a missile could navigate on its own, truly on its own, the entire concept of defense began to shift. Radar systems were designed to detect high-altitude threats. This missile flew low.
Too low.
Air defenses were designed to respond to fast, direct attacks. This missile approached indirectly.
Unpredictably.
Defensive strategies relied on knowing where the attack would come from. This missile could come from anywhere. It wasn't just a technological advancement.
It was a philosophical one.
War, for centuries, had been reactive. You see the enemy.
You respond.
You adapt in real time. But now, for the first time, a weapon could act with premeditated precision across vast distances, independent of human correction once launched.
It didn't panic. It didn't hesitate.
It didn't lose sight of the objective, because it never needed sight to begin with. Back in those early development years, the Tomahawk wasn't yet the symbol it would become. It was still a project.
A theory.
A promise waiting to be proven. But inside that promise was something far greater than a new missile. It was the collapse of a long-held belief. The belief that darkness protects. The belief that distance shields. The belief that if you cannot be seen, you cannot be struck. And as engineers refined circuits, tested guidance systems, and fed terrain data into early computers, that illusion began to crack. Not loudly. Not dramatically. But inevitably. Because once a weapon no longer needed to see, there was nowhere left to hide. Before it became a whisper over deserts and a verdict over hardened steel, the Tomahawk was something far less certain.
It was a gamble.
Out in the remote test ranges of the American Southwest, where heat shimmered off endless stretches of Al-Ardi and the horizon felt like it belonged to no one, engineers gathered around monitoring stations. Eyes fixed not on the sky, but on screens. Because what they were testing could not be followed by sight alone. The missile sat on its launcher, unassuming, almost modest in appearance.
No towering fram.
No roaring engines like a fighter jet. No dramatic presence that commanded attention. It didn't look like a revolution. And that was exactly why many doubted it. They had seen ambitious projects fail before. Complex systems that worked perfectly in theory but collapsed under real-world conditions. Electronics that faltered under stress. Guidance systems that drifted, miscalculated, or simply lost their way. And this system, this idea of a machine navigating terrain autonomously, depended on everything working flawlessly. There was no pilot to correct mistakes. No second chance once it launched. The first ignition came with a burst of flame and a surge of controlled al-Quwa. The missile lifted, stabilized, and then, almost immediately, it disappeared from sight, dropping low, hugging the terrain exactly as designed. And that's when the real test began. Inside the control room, the atmosphere was tight. Conversations were short. Every eye moved between streams of data, altitude readings, velocity, positional corrections. Because out there, beyond visual range, the missile was making decisions. You see, Turcom wasn't magic.
It was comparison.
The onboard system scanned the Al-Ardi below using radar altimetry, creating a real-time profile of hills, valleys, and contours. That data was then matched against preloaded digital maps stored inside the missile's memory. If the match was close enough, it stayed the course. If it drifted, it corrected. But close enough was a dangerous phrase in warfare. Early tests proved just how fragile that balance could be. There were flights where the missile veered off course, not dramatically, but enough to miss a target by miles. Small discrepancies in terrain data. Slight miscalculations in altitude. Errors that, to a human eye, might seem insignificant, but to a machine relying on exact patterns, they were catastrophic.
They failed. Again and again.
Missiles that should have struck precise coordinates instead landed wide, off-target, sometimes disappearing into empty stretches of desert. Each failure wasn't just a technical issue.
It was a question.
Was the idea itself flawed?
Critics grew louder.
They said the system was too dependent on perfect data.
Too rigid.
Too slow to adapt to the unpredictable nature of real Al-Ardi. They argued that war wasn't a controlled environment, it was chaos. And chaos broke machines like this. But what they didn't see was what America does best under pressure. It doesn't abandon systems. It refines them. Engineers went back to the fundamentals. They recalibrated sensors, improved resolution, enhanced the fidelity of terrain mapping. They didn't just feed the missile data, they taught it to interpret that data more intelligently. And then came another breakthrough. DSMAC, Digital Scene Matching Area Correlation. If Turcom was about understanding the shape of the Al-Ardi, ZMAC was about recognizing its face. In the final phase of flight, the missile would compare visual images of the target area with stored references.
Buildings.
Road patterns. Landmarks. It wasn't just matching contours anymore. It was identifying the target itself. The missile wasn't just navigating. It was confirming. That changed everything. Because now, even if earlier guidance phases introduced slight errors, the final approach could correct them with astonishing precision. The system didn't just know where it was. It knew where it was supposed to be. Another test was scheduled. Same desert.
Same tension.
But this time, something was different, not in the hardware alone, but in the confidence of the people watching.
The missile launched.
Again, it disappeared into the low horizon, invisible to the naked eye.
Minutes passed. Data streamed.
Corrections executed silently, flawlessly.
And then, the final phase.
ZMAC engaged. The missile's onboard vision locked onto its target profile. Not by sight as humans understand it, but by recognition. A structure, long designated as the target, waited miles away, silent, unaware. Inside the control room, no one spoke.
And then it happened. Impact. Direct. No drift.
No deviación.
No second guessing. Just precision. Measured.
Calculated. Absolute. For a moment, there was no celebration.
Just a quiet realization settling over the room. They had done it. They had built something that could find its way across hundreds of miles, without eyes, without guidance, without hesitation, and strike exactly where it was intended. They had taught a machine to navigate the world not through sight, but through understanding. They laughed at its complexity. They stopped laughing when it started hitting targets they couldn't even see. Because this wasn't just about accuracy anymore. It was about inevitability. Once launched, the Tomahawk didn't need rescue.
It didn't need adjustment.
It didn't need courage in the traditional sense. It carried something else.
Certainty.
And in warfare, certainty is more powerful than speed.
More powerful than armor.
More powerful than fear itself. Because when a weapon knows exactly where it's going, and nothing can stop it from getting there, the outcome isn't a question anymore.
It's a conclusion.
And somewhere beyond the test ranges and the quiet breakthroughs, the world was still holding onto its old beliefs, about darkness, about distance, about safety through invisibility. They didn't know it yet. But those beliefs were already obsolete. January 17, 1991. The opening hours of Operation Desert Storm. The desert air was still, almost unnaturally calm, the kind of silence that exists just before something irreversible happens. Across Iraq, radar operators stared into glowing screens, scanning for the familiar signs of incoming attack, high-altitude bombers. Fast-moving aircraft, the sharp signatures of threats they understood. They were ready for war. But they were ready for the wrong kind of war. Hundreds of miles away, far beyond the reach of immediate detection, U.S. Navy vessels cut silently through the waters of the Persian Gulf. Beneath the surface, submarines held position with cold discipline. On deck, launch systems stood prepared, not for a barrage of chaos, but for something far more calculated. The command was given. And one by one, the missiles left their tubes. There was no dramatic roar echoing across the sky. No visible formation of aircraft sweeping toward the horizon. The launches were controlled, almost restrained, a series of ignitions that sent each Tomahawk forward with quiet determination.
Then they were gone. Low. Invisible. Unstoppable.
You see, what made this moment different wasn't just the weapon itself, it was the method. For the first time in large-scale combat, a nation was striking deep into enemy territory without exposing pilots. Without announcing its presence through traditional means, without giving the defender a clear signal of where the blow would land. The missiles flew beneath radar coverage, tracing paths that had been calculated long before the first launch. They followed valleys, curved around natural obstacles, adjusted their routes not by reaction, but by design. To Iraqi defense systems, the sky remained eerily quiet.
No incoming bombes.
No formations to intercept.
Nothing to fight.
And that was the most terrifying part. Because war, as they understood it, always came with warning.
A build-up. A sound.
A visual confirmation that danger was approaching. But this came with none of those. Inside one Iraqi command bunker, deep beneath reinforced concrete, officers monitored communications, expecting reports of air engagements. They trusted their defenses. Trusted the layers of protection that had been built to withstand exactly this kind of assault. They believed they were hidden. Protected by darkness. Protected by depth. Protected by the limits of what an enemy could see. What they didn't know was that sight was no longer required. Miles away, a Tomahawk descended into its final phase. Turcom had guided it across vast stretches of terrain. Zmak now took over, comparing the visual fingerprint of the target area with the data stored inside its memory. Buildings, patterns, structures, all aligned. The missile didn't hesitate. It confirmed. And then it struck. The explosion wasn't just a blast of force, it was a message.
Precise. Controlled. Devastating.
A direct hit on a target that had never been exposed to the human eye during the attack. Back in the bunker, shock rippled through the command chain. There had been no warning. No time to react.
No interception.
Just impact.
They searched their systems for answers. Radar logs showed nothing significant. No high-altitude intrusions. No fast-moving threats.
Just silence. And then destruction.
They brought defenses built for speed. America brought a weapon built for certainty. Across the region, similar strikes unfolded. Communications hubs went dark. Air defense nodes were disabled. Strategic targets, once considered secure due to their location or concealment, were hit with an accuracy that seemed almost impossible.
It wasn't saturation bombing.
It wasn't overwhelming force in the traditional sense.
It was surgical. Each strike chosen. Each path calculated. Each impact intentional.
For pilots like Captain Harrigan, the battlefield had transformed overnight. Missions that once required risky penetration into heavily defended airspace were now supported, even preceded, by weapons that cleared the way.
Invisibly.
Targets that would have demanded multiple sorties, multiple crews, multiple risks, were now neutralized before a single aircraft crossed into danger.
War had changed. Not gradually, but instantly.
The Iraqi military had prepared for an enemy they could see. What they faced instead was an enemy that could reach them without ever appearing. They thought depth would protect them. They thought darkness would shield them. They thought distance would buy them time.
They were wrong.
Because the Tomahawk didn't just close distance. It erased it. And that's when the realization spread, not just through Iraq, but across every military watching that conflict unfold. If a target could be mapped, it could be struck. If a location could be defined, it could be reached. There were no more safe assumptions. No more guaranteed shelters behind layers of al-ardi and steel. Because somewhere, beyond the horizon, a system could already be calculating the path to your door. They laughed at the idea of a slow, complex missile. They stopped laughing when it arrived without warning. Because in that moment, the rules they had built their defenses on, visibility, detection, reaction, all collapsed at once. War was no longer about reacting to threats. It was about surviving inevitability. And as the first night of Desert Storm unfolded, lit not by visible waves of bombers but by precise,
unseen impacts,
the world understood something it could never unlearn. The battlefield was no longer defined by what you could see. It was defined by what could find you. What the world witnessed that night in 1991 wasn't just a new weapon proving itself. It was a system, revealing its full weight. Because the Tomahawk, for all its precision and intelligence, did not exist in isolation. It wasn't a miracle of a single idea or a single breakthrough. It was the product of something far larger. Something uniquely American. You see, other nations could build weapons. Some could even match raw specifications, speed, range, payload. But what they struggled to replicate was the ecosystem that made a weapon like the Tomahawk not just possible, but reliable, repeatable,
and scalable.
Because precision is not just engineering. It's infrastructure. Back in the United States, long before the first missile ever flew over Iraq, a different kind of battlefield had already been won. One fought not with explosions, but with data coordination and relentless industrial discipline. Maps had to be created. Not simple maps, but digital terrain models of entire regions. Every hill, every valley, every contour of al-ardi had to be measured, recorded, and converted into data that a machine could understand. That wasn't a small task. That was a national effort. Satellites orbited above, gathering imagery with increasing resolution. Reconnaissance aircraft flew missions not to attack, but to observe, to record. To build the digital memory that Tomahawk missiles would later rely on. Engineers processed that information, refining it, compressing it, encoding it into guidance systems that could fit within the missile's compact frame. And then came the manufacturing. Assembly lines didn't just produce missiles. They produced consistency. Each Tomahawk had to perform exactly like the last, not approximately, not close enough, but precisely. Guidance systems calibrated to exact tolerances. Engines tuned for stable, low-altitude flight. Electronics hardened against interference, vibration, and the unpredictable realities of combat environments. This wasn't craftsmanship in the old sense. This was industrial precision. They brought ingenuity. America brought repeatability. Because a weapon that works once is a success. A weapon that works every time is dominance. Inside naval vessels, another layer of the system came into play. Launch platforms weren't static installations, they were mobile, flexible, constantly repositioning. Destroyers, cruisers, submarines, each one capable of carrying and deploying Tomahawk missiles from positions the enemy couldn't predict.
That mobility mattered.
Because it meant the point of origin could shift. The direction of attack could change. The battlefield became fluid, not fixed. And then there was the integration. Targets weren't chosen randomly. They were selected through intelligence networks that combined satellite data, signals intelligence, human analysis, and strategic planning. Each strike wasn't just about destruction. It was about effect. Disabling a radar site didn't just remove a single node, it opened corridors for follow-on operations. Eliminating a command center didn't just remove leadership, it disrupted coordination across entire regions. The Tomahawk wasn't just hitting targets. It was reshaping the battlefield before the main force even arrived. And that's what many observers missed at first. They saw the explosions. They measured the accuracy. But they didn't fully grasp the system behind it, the invisible network of data, production, logistics, and doctrine that made those strikes possible. Because this wasn't about one missile flying correctly. It was about hundreds, all doing the same thing, across different trajectories, against different targets, with the same level of precision. That kind of consistency doesn't come from luck.
It comes from design.
They brought isolated capabilities. America brought integration. Back in the Gulf, as operations continued, the pattern became undeniable. Key infrastructure was neutralized with minimal exposure of U.S. personnel. Air superiority was achieved faster. Ground operations faced less resistance. Not because the enemy lacked courage, but because their systems had been quietly dismantled before they could fully respond. For the men and women operating within this system, from engineers to sailors to analysts, the Tomahawk represented something deeper than just a
successful weapon. It was proof.
Proof that a nation built on industry, on coordination, on the ability to connect ideas into functioning systems, could change the very nature of conflict. Because in the end, wars are not won by moments alone. They are won by processes. By the ability to turn innovation into production, production into deployment, and deployment into decisive action. And that's where the true power lay. It wasn't just that America could build a missile that could see without eyes. It was that America could build thousands of components, integrate them into a seamless system, and deploy them across the globe with precision and confidence. They thought they were facing weapons. They were facing a machine. A machine built not of steel alone, but of data, discipline, and design. And once that machine was in motion,
it didn't stop.
Because this wasn't about a single strike. It was about a new standard. One where every target could be mapped. Every path could be calculated. Every outcome could be engineered. When the fires dimmed and the desert wind carried the last traces of smoke across Iraq, something far more lasting than destruction remained.
A realization. Not loud. Not immediate. But irreversible.
For decades, nations had invested in concealment, in bunkers, in terrain, in the belief that survival could be engineered through invisibility. They buried their command centers deeper. They layered defenses thicker. They trusted that if they could not be seen, they could not be touched. That belief did not shatter in a single explosion. It dissolved, quietly, methodically, as evidence accumulated.
Strike after strike.
Target after target. Each one reinforcing the same truth. Distance no longer protected. Darkness no longer concealed. Depth no longer guaranteed survival. Because the Tomahawk had done something no weapon before had fully achieved. It removed uncertainty from the equation. You see, war had always been a balance of probabilities. Even the most carefully planned operations carried risk. Variables that could not be controlled, factors that could not be predicted.
Weather shifted. Pilots erred. Targets moved.
There was always doubt. But now, for the first time, a weapon system had demonstrated something close to certainty. Not perfection, war never allows that, but a level of reliability that changed how decisions were made. Commanders no longer asked, "Can we reach it?" They asked, "When do we strike?"
That shift mattered.
Because strategy is built on assumptions. And when those assumptions change, everything built on top of them must change as well. Across the world, military planners began to rethink their defenses. Hardened bunkers were no longer enough. Camouflage was no longer sufficient. Even mobility, once a reliable countermeasure, became less effective when an enemy could pre-program routes and adapt mid-flight.
They brought concealment.
America brought inevitability. And with that inevitability came a new kind of deterrence. Not the kind built on overwhelming visible force, fleets, formations, displays of power meant to intimidate.
But a quieter kind.
A knowledge that, if necessary, a response could come without warning, without exposure, without the traditional signs of escalation. A knowledge that somewhere, beyond the horizon, systems were already capable of reaching you. That kind of power doesn't shout.
It waits.
Back in the United States, the legacy of the Tomahawk continued to evolve. Guidance systems improved. Navigation integrated satellite positioning, adding another layer of accuracy.
Data processing became faster, more refined. The system didn't stand still. It advanced.
Because that's the nature of what had been created. This wasn't a single invention frozen in time.
It was a foundation.
A proof that warfare could move beyond human limitation. Not by removing humans from the equation, but by extending their reach, their precision. Their ability to shape outcomes from distances once considered impossible. For the veterans who watched these changes unfold, there was a mix of emotions. Pride, certainly, in the ingenuity, in the discipline, in the ability to build something that worked not just in theory, but in the unforgiving reality of combat.
But also something deeper. An understanding.
That what they had witnessed was a turning point. The kind that only comes once in a generation. Because moments like this don't just change battles. They change expectations. From that point forward, every nation had to assume that its most protected assets were no longer beyond reach. Every strategy had to account for an opponent that could strike with precision, from distance, without exposing itself. The game had changed.
Not by accident. Not by chance. But by design.
They once laughed at the idea of a missile that could think its way across a battlefield. They stopped laughing when it arrived, exactly where it was meant to. Because in the end, the Tomahawk was never just about destruction. It was about transformation. It turned geography into data. It turned distance into a calculation. It turned darkness into a pathway. And in doing so, it redefined what it meant to wage war. Courage still mattered.
It always would.
But courage alone was no longer enough. Because as the 20th century drew toward its final decade, one truth stood above the rest, clear, undeniable, and written not in words, but in precision strikes across a desert sky. They brought myths.
America brought math.
And from that moment on, the future of warfare no longer belonged to those who could hide. It belonged to those who could calculate. And somewhere in that silent, unseen path between launch and impact, the era of blind warfare ended. The era of American precision began.